guys will learn about parallel and perpendicular lines. So they're two different sets of lines, and we'll have a look at it. So if two lines are parallel, hence these ones over here, they both have the same gradient. So this sort of notes I would like you to write down. It might already be in your booklet, but if not, can you please copy this down? So it has the same distance and it has the same gradient. As you can see, if this line and this line are parallel, because if you keep extending it this way or this way, they will never touch each other. Right? So draw the parallel lines, write some notes on it. So draw an example of parallel line in your booklet. So for lines which are neither horizontal nor vertical, the lines are parallel if and only if their gradients are equal. So this is the most important part. So what I would like you to make notes on is something like this. So write parallel lines, write gradients are equal. So this is the most important part. So draw maybe an example for as parallel as you can draw. This is an example of a parallel line. So this is really all I want you to write down in your booklet, and we're going to write some notes for perpendicular lines. Now perpendicular lines are right angles to each other, right? So 90 degrees. So as you can see, two lines are perpendicular if they are right angles of each other. So I want you to draw this example. Make sure you write right angles. Make sure you write perpendicular lines. So this is all going in your booklet. You don't have to write every single thing that's on this page, just the little notes that I'm making. But the gradients are not the same for perpendicular lines. What they are, though, is they are called negative reciprocals. So let's write that down. So let's write gradients are negative reciprocals. Now, I'll tell you what that means. Basically, if you have two perpendicular lines, gradient m1 and m2, when you times them together, it becomes -1. So if I have gradient number 1 times gradient number 2, it becomes -1. So what that means is, for example, let's say, we'll look at this example actually. So this is the only notes you need to write for perpendicular lines, and this yellow box over here is what you need to write for parallel lines. So that should be copied in your booklet above the example 9, and then underneath the example 9 we're going to do some examples. So for this one, we want to figure out, find the gradient of lines perpendicular to a line with a gradient of 2/7. So I'm just going to show you how to do it rather than try to explain with different examples. All you have to do is, there's two rules you have to do. First of all, so first step, what you have to do is flip the fraction. Okay, so 2/7 becomes 7/2. Then the second step you have to make sure you do is change the sign. So in this case, ours is a positive 7/2. Now because it's a positive, you want to change it to a minus. Okay, that's all. So this becomes your answer. So that's your answer. So the gradient of a perpendicular line to a line that has a gradient of 2/7 is just simply minus 7/2. That becomes the new gradient. So basically, you've got two perpendicular lines. If this gradient m, we use the m symbol for gradient, was 2/7, this line has a gradient of minus 7/2. So that's the relationship. Okay, so let's have a look at b. Same rule, so you have to flip the fraction. But do you notice how my b is not a fraction? But good thing I know how to make -5 into a fraction really easily. You just go divide 1. So all I have to do is flip the fraction and go 1/-5. And I have to make sure I do the step 2, which is change the sign. Do you notice how it's already a minus? So all I have to do is just get rid of the minus and just write it as a positive answer. This is your final answer. What that means is, I've got my perpendicular lines, let's say. If one of them is -5, the other one is 1/5. Now let's just use this knowledge of you know, 2 gradient times together becomes -1. Let's just double check that. So basically what that means is for example A, if I times them together, if I go gradient number 1 times gradient number 2, sorry, if I times them together, it becomes -1. Great. For this one, if I go gradient number 1 times the gradient number, gradient number 2, it becomes -5 over 5, so it becomes -1. See, both works. So now you should be able to do these questions, so go ahead and do those, and maybe pause the video and do it, and then I'm going to do this example as well, so you can keep watching once you've done those examples. Alright, so what we have to do for this one, so please, if you haven't done this already, pause the video now and then go do these first, and then come back to the video, please. Alright, find t, given that the line joining d, -1, -3 to c, which is 1, t, is perpendicular to a line with gradient 2. Okay, so if this line, D and C, whatever it looks like, maybe I'll draw it a little bit like this. So let's say we have D and C. I don't know what it looks like. If that is perpendicular to a line with gradient m equals 2, we know what the gradient D and C will have. It's just negative reciprocal, meaning, you know, divide 1, I swap the fraction and then add a negative. So we know that D and C have the gradient of -1 over 2. So that's what I gotta do. I use this D and C. So let me copy it down. And then I use the gradient formula to figure out and rearrange to find t. So step 1's always the same. I will label them. Remember, we know how to find gradients. If not, go back to gradient example, which is 13C. Maybe you didn't do enough homework. So if you have no idea what I'm doing, you might need a little bit more help with 13C. And then we write the formula. So the gradient is sub it in. So now I know that this should equal my gradient. So I'm going to equal it to -1 over 2. This is what I'm just trying to solve now. I just got to cross multiply, easy peasy, and solve for t. So 2 lots of t plus 3 equals the other diagonal, which is -2. So all I'm going to do is get rid of the 2. You could expand as well, doesn't matter. So I have t plus 3 equals -1. Almost done now, I just got to get -3, get rid of it. So my t must be -4. So I found my t, and that's it. So now, once you do that example in your booklet, you should be able to do these questions as well. Okay? So I'm going to stop it there. Today's class, I want you to finish all of this, and then tomorrow we'll hopefully be able to look at example 11.